Hello and welcome to Engineering Insights, the podcast where we dive deep into the world of innovation, discovery, and technology. I'm your host, Methink, and I'm absolutely thrilled to have you here with me today. In this episode, we're exploring the fascinating world of engineering research, what it is, why it matters, and how it's shaping the future, especially in the ever-evolving field of mechanical engineering. Whether you're an engineer, a student, or just someone who's curious about how the world around you works, this episode is just for you. By the end of our time together, you'll gain a deeper understanding of the nature and characteristics of engineering research, along with some real world examples that truly highlight its incredible impact. So grab your coffee, settle in, and let's jump right in. Let's start with the basics. What exactly is engineering research? At its core, engineering research is the process of solving technical challenges, developing innovative technologies, or advancing our theoretical knowledge of engineering principles. It's a field that sits at the intersection of theory, experimentation, and practical application. Unlike pure scientific research, which focuses on understanding natural phenomena, engineering research is often application driven. It aims to create solutions that can be implemented in the real world, whether that's a new machine, a more efficient manufacturing process, or a groundbreaking material. Why does this matter? Well, think about it. Think about it. Everything from the car you drive to the phone in your hand exists because of engineering research. It's the backbone of technological progress and a key driver of innovation in every industry. So, if you've ever wondered how engineers turn big ideas into practical realities, engineering research is the answer. Now that we know what engineering research is, let's talk about its key characteristics. What sets it apart from other types of research? First, engineering research is highly problem solving focused. It's not just about exploring ideas for the sake of knowledge, it's about addressing specific challenges. For example, how can we design an engine that's both more powerful and more fuel efficient? Or how can we create materials that are lightweight yet incredibly strong? Second, it's inherently interdisciplinary. Take mechanical engineering, for instance. It often overlaps with fields like materials science, robotics, computer science, and even biology. This collaboration across disciplines is what makes engineering research so dynamic and impactful. Third, engineering research is iterative and rigorous. The process usually involves designing a solution, testing it, analyzing the results, and refining the design based on what works and what doesn't. This cycle can repeat multiple times until the desired outcome is achieved. Fourth, it relies heavily on a quantitative approach. Engineers use mathematical models, simulations, and data analysis to validate their designs and predict performance under various conditions. This ensures that the solutions are not only innovative, but also reliable and efficient. And finally, engineering research is application-oriented. While it may involve a lot of theoretical work, the ultimate goal is always to create something tangible that solves a real-world problem. Let's bring this to life with some examples of mechanical engineering research in action. One exciting area is robotics and automation. Researchers are constantly working on advanced robotic systems that can perform complex tasks with precision. For example, robotic arms used in manufacturing are being designed to work faster, more accurately, and more safely alongside humans. Another hot topic is renewable energy. Mechanical engineers are playing a critical role in improving technologies like wind turbines, solar panels, and energy storage systems. These innovations are helping us transition to a more sustainable energy future. Additive manufacturing, or 3D printing, is another game changer. Mechanical engineers are developing new materials and methods to make 3D printing more versatile and precise, enabling applications in industries like aerospace, healthcare, and automotive. And let's not forget thermal systems. From improving HVAC systems to designing more efficient heat exchangers, research in this area has a direct impact on our daily lives. Here's a real-world example. Imagine designing a lightweight material for an airplane. Researchers might use computer simulations to test how different materials perform under stress, then create a prototype for testing in the lab. Once they identify the best material, it could lead to airplanes that are both safer and more fuel efficient. Isn't it amazing how mechanical engineering research touches so many aspects of our lives? Of course, engineering research isn't without its challenges. Funding can be a significant hurdle, especially for projects that require expensive equipment or long term studies. Collaboration with industry is often essential to overcome these barriers, but balancing innovation with practical feasibility can be tricky. Ethics also play a big role in engineering research. For instance, researchers must ensure that their designs are safe, sustainable, and compliant with regulations. There's also the broader question of how technology impacts society. For example, while automation can boost productivity, it also raises concerns about job displacement. These are the kinds of issues engineers must navigate as they innovate. If you're an aspiring mechanical engineering researcher, here are a few tips to get you started. First, develop strong analytical and programming skills. Tools like MATLAB, Python, and CAD software are essential for most research projects. Second, get hands-on experience through internships, lab work, or personal projects. The best way to learn is by doing. Third, collaborate with others. Engineering research is rarely a solo endeavor, so being able to work effectively in a team is crucial. Finally, stay curious. The field of mechanical engineering is constantly evolving, so make it a habit to keep up with the latest research and technologies. That brings us to the end of today's episode. We've explored the nature and characteristics of engineering research, delved into its application in mechanical engineering, and discussed the challenges and opportunities it presents. Mechanical engineering research is at the forefront of solving some of the world's most pressing problems, from renewable energy to advanced robotics. It's a field full of innovation, creativity, and potential. If you enjoyed this episode, don't forget to subscribe to Engineering Insights and share it with your friends and colleagues. You can also leave a review to let us know what you think. We love hearing from our listeners. Thank you for tuning in, and until next time, keep exploring, keep innovating, and keep engineering the future. Goodbye.